Let's dive right into this explainer and address a completely critical security gap in today's rapid vibe coding landscape. Right now, anyone can spin up an application in a weekend just by chatting with an AI. It's incredibly empowering, but that unprecedented speed, it's creating a massive security blind spot. So today, we're going to break down exactly how to secure your AI-generated code using a highly practical whiteboard workflow. What's really interesting here is how perfectly this captures the core tension. The speed of AI literally outpaces our traditional security boundaries. The dangerous part of vibe coding isn't that beginners are suddenly building tools. Not at all. The real danger is that a fun, experimental weekend app can morph into public-hosted business software practically overnight, usually way before the builder even realizes their security obligations have fundamentally changed. Take a look at this recent reporting from The Verge. It highlights exactly what happens when personal AI prototypes jump straight into hosted business environments without any safety net. We're seeing exposed production databases, embarrassingly weak authentication, and just massive exposure of sensitive data. It turns out, AI definitely changed who can build software, but it absolutely hasn't changed what attackers are looking for. Just to put some scale to this problem, researchers found roughly 5,000 publicly accessible apps built with popular vibe coding tools that had zero authentication. 5,000. That means anyone on the internet with a web browser could basically just walk right through the front door of these applications. And the fallout from that is severe. Close to 2,000 of those apps appeared to actively leak sensitive data. We're talking medical information, financial records, internal strategy docs, private chatbot logs, the whole shebang. This isn't just a theoretical risk anymore. This is real data sitting right out in the open, simply because deployment speed totally outpaced security discipline. So we really need to understand the exact threshold where a fun local prototype transforms into a high-risk public obligation. Look, if your app only runs locally on your machine and tracks something low risk, maybe your personal workout routine, the danger is minimal. But the absolute second you push that app to a public host, you cross a line. You are now fully responsible for the security of that digital environment. Now, a skeptical analyst might jump in right about here and ask, come on, do these massive enterprise security rules actually apply to solo creators, non-traditional builders, and my simple side projects? It feels like way too much overhead for a weekend build. Well, the answer is a resounding yes. The moment your weekend project touches customer logs, financial records, medical info, private messages, internal documents, or account tokens, it is no longer just a toy. The data dictates the risk, and touching this kind of data instantly makes your application a prime target. So, the crucial takeaway is this highly practical 5-check workflow you absolutely must run before hitting publish. Think of this as your non-negotiable launch gate. You map your data, add authentication, scan for secrets, review your dependencies, and commit to continuous review. Master this list, and you can vibe code as fast as you want without exposing yourself to massive liability. Let's move to the first two gates. Check 1, map data, and check 2, add authentication. Before you can even think about securing an app, you have to know exactly what sensitive data flows through it. This is data mapping. What does it touch? What does it store? What does it transmit? Because if you don't know it's there, you can't protect it. And once you've mapped it, you immediately hit check number 2, add authentication. Lock the front door before you invite the entire internet over. At this point, that skeptical analyst might interject again, wondering, hey, if the AI is smart enough to build the app, why can't I just use natural language to tell it to make the app unhackable? Why not just prompt, make this secure? It's a tempting shortcut for sure, but here's the reality. While AI can definitely help if it's given the exact right threat model context, like telling it exactly who might attack the app and what they want, treating its output as a certified security guarantee is a massive mistake. A model can review code and completely miss the fact that your public app is using the wrong database permissions. You need boring, reliable, deterministic tools to create a minimum security floor. Remember, AI is your builder, not your auditor. Okay, let's dive into checks 3 and 4, scan secrets and review dependencies. This official OWASP Top 10 maps out the exact risks specifically designed for large language model applications. Look closely at LLM-05, supply chain vulnerabilities, and LLM-07, insecure plugin design. When your AI pulls in third-party packages or designs plugins to make your app work, it is very often introducing hidden risks. You also have to watch out for prompt injection and insecure output handling. Basically, you have to review the dependencies your AI chooses just as rigorously as the code it writes itself. And speaking of the code it writes, you absolutely must scan for hard-coded credentials. AI coding agents are incredibly helpful, but let's be honest, they're also kind of lazy. For convenience, they will often leave API keys, passwords, access tokens, and database connection strings sitting right there in the raw code. If you push that to a public repository, those secrets are compromised in literally seconds. So, check 3 is actively scanning for these secrets. Now, what's really great is that standard platforms like GitHub actually provide automated pipelines to catch these boring mistakes before they ever merge. GitHub secret scanning actively looks for hard-coded credentials across your entire repo history, while CodeQL searches for known vulnerabilities. You don't even have to do this manually. You just have to remember to turn these boring tools on. Let's move to the final check, continuous review. Security is not a one-time launch event. You don't just secure it on Friday and forget about it on Monday. It requires manual, continuous review every single time your agent pushes an update. Even when the AI is just writing a quick patch to fix a bug, you have to review that patch. Every meaningful change resets the security board. Let's look at the real-time application lab. This framework shows exactly how a non-traditional builder should handle different tools based on their specific risk profiles. Building an internal dashboard? Use local fake data first and definitely add auth before moving it to a cloud host. Spinning up a client portal? Map every single stored field and implement strict role-based access checks. Creating a finance planner? Keep your API keys out of the code entirely, put them in a .env file, and always run secret scanning. A really great practical example of keeping things safely scoped is Howard's Side Hustle Command Center from Cognitive Capital. It's an AI-built dashboard, but what makes it so smart is that it explicitly keeps its scope purely educational. It runs locally, it manages user expectations by not offering financial advice, and it restricts data flow to protect the user. By deliberately limiting the scope, you organically limit the security risk. Ultimately, the entire goal of this explainer isn't to stop you from building quickly. Keep building, keep vibe coding. The goal is to make this red to green launch gate as normal and as automatic as your initial prompt to the AI. If your data map or auth is missing, launch blocked. When all 5 checks are green, you ship. And this perfectly illustrates our ultimate takeaway. Speed without discipline is just exposed liability. Vibe coding gives you the absolute superpower to create software at the speed of thought. But that advantage completely evaporates the minute you're dealing with a massive data leak because you skipped the basics. So I want you to look at your own projects right now. Look at the code your AI agents are writing for you today. Ask yourself this final, critical question before you hit publish. Which check would catch the most risk in your current setup? Is it mapping the data, adding authentication, securing secrets, reviewing those dependencies, or just stepping up your continuous review? Figure out exactly where your blind spot is, apply this checklist, and build safely.